Hey everybody, Chris Harrold back with you. I'm going to keep the intro super short this time because we got a lot of stuff to get through. I'm really excited today. I've got my soil moisture project actually up and running. The prototype's all finished. We're going to look through that today. We'll show you the code. We'll show you how it works. Show you how to wire it up. It's going to take a lot to get through, so I'm going to move the camera into a better spot so you can see everything, and we'll get rolling. Thanks for joining me today. All right, so for those of you who've watched the series so far, you know that one of the things about the Raspberry Pi is that it is a digital only device. So all of the pins that it receives signal from sensors on are designed effectively to be turned on or off by that signal. So it's a 1 or a 0. Really good for detecting threshold values like a high or a low value. Not so good for reading a scale of values. And in our case, because we want to use a soil moisture sensor, the scale actually matters because I want to track moisture levels over time and see how it helps or hurts the growth and performance of my plants. So I need to effectively change this digital device into an analog one. In order to do that, there's lots of ways out there. There's hardware and software methods that you can hook this up. I have chosen an MCP, that's Mike Charlie Papa 3008 chip. That is an analog to digital converter. You can see it here on the little breadboard to the left. It is a 10-bit, 8-channel ADIC converter, so analog to digital converter. It is wired up. I am not going to walk you through all the wiring up process. It would take us probably 15 minutes just to plug all the wires back in. Suffice to say, there are some really good guides to this online. In fact, the one that I used is on the adafruit.com website, learn.adafruit.com, and it was written by Tony DeCola, and it's called Raspberry Pi Analog to Digital Converters. And it tells you how to use the Python libraries, where to get them, how do pinouts work, how to wire everything up. It's very, very useful. Walk you through the whole thing. And it was extremely straightforward and well documented. So, Tony DeCola, if you ever happen to watch this, thank you very much, man. You helped me out a lot. So that's now made us able to read both digital and analog signals at the same time, which we're going to do with our rig. So I'm going to move this out of the way for a second, if I can. And slide in our sensor package, which looks no less like a rat's nest of wires, because it is. This is one thing you will find about doing Raspberry Pi projects on breadboards. If you are just using the wires that come in the box and not, pinning and stripping your own down and making shorter ones, this is basically what every project looks like. So it's not so bad. It's great for prototyping. So I've got 3 sensors on this sensor pack, actually. I've got my soil moisture sensor. Here's the probe end of that, right? So it looks like a little tuning fork. And this is the actual sensor. Now, this little potentiometer here, that's the little screw head right there, we're not going to use that. That's for the digital signal. And again, if you wanted to trigger when water falls below or goes above a certain level, you would need to adjust with a little screwdriver the potentiometer here to set your trigger point. We don't need that because we want to read all of the values that it will spit out because we're using an analog mode. Back here, of course, I have my light sensor. This is something that I added in after the fact, both because I wanted to show you guys how it worked, but also because there's no reason to monitor soil moisture overnight. Generally, evaporation, especially here in a dry, cool climate where the evenings are much cooler in Denver, it's not as big a deal. There's one thing that you should note about the soil moisture sensor. The more often you measure it and put power to it, the faster that these contacts corrode. And once they corrode, it doesn't work anymore. So I'll show you when we run the code how I've gotten around that in a couple of different ways. One of them is the light sensor, so I don't check at night. The other one is that I only turn on the sensor package long enough to take a reading, and then I turn it back off. And I'll show you how I've got that set up. Then this last one here, so I mucked around with a different temperature sensor for a long time, and I spent several really probably a week and a half, between regular day job, trying to find code to make that temperature sensor spit me out a real temperature. I tried every possible combination I could find online, and none of them worked. And then I read about the specs on this sensor. This is called a DHT, Delta Hotel Tango 11. It's a temp and humidity sensor, and the humidity is actually nice to know because it plays a role in evaporation and in helping your plants stay watered. So that's a great little resource. Plus, it spits out a native Celsius temperature that I don't have to do any fancy math to get. So I was pretty excited to find that, frankly, and I decided to switch over to this. It was really easy to use. All the code, of course, to enable it is in the GitHub repository. You've got the link there on your screen right now, and you can very easily embed that DHT11 code into your own project. So I'm going to pause the recording and get this rewired up. And again, the wiring is less important. I'm using a shared ground, which is why I've got 3 ground wires here. I'm going to share the ground back to the main breadboard. I've got shared power as much as I can, again, to turn the sensors on and off. And then all these blue wires are just going to go to the appropriate pins to read the values that come off the sensor. So 2 of them are analog. One of them is actually a digital output. Because of the way the DHT11 works, it doesn't output an analog signal. It only outputs in digital. So that's going to go directly back to the Raspberry Pi breadboard over here. So I'm going to wire those back up real quick, and then we'll go ahead and look at how this all works. Okay, so that's that all wired up. So I've got a shared ground for all the sensor devices on here. I'm just using the minus rail on this side of the breadboard. I've got a shared power so that I can turn the sensor pack on and off. Again, as I mentioned, that's mostly to prevent corrosion of the probes here on the soil moisture sensor on the business end here. And then I've got the various readings that'll come off the chip. So one is for my light sensor, one is for the soil moisture sensor itself, and then this reading is actually a digital one, so that goes over here to one of the pins on the Raspberry Pi. What we can do is go ahead and we'll click over here to our code. And so I've got this, of course, up in the GitHub repository. So the first thing I'm going to do as a best practice is I'm going to git pull. I updated the README just so that I could make sure that I got my updates down. And the name of the file here is this h2o sensor.py. I'm not going to walk you through the whole code. It's extremely heavily commented. Should be able to figure out what's going on just by reading through the code comments. But let's walk through what the code actually does. So we're going to run this here. Oops, if I could type good. In our sudo under Python, of course, because it's written in Python. So it's going to tell me it's preparing to monitor the soil moisture level. You probably well, you can't see it because we're looking at the screen, but you can tell that the sensor pack has come on because a little red light goes on the soil moisture probe when the power is applied via the power rail. So that's how you know it's turning the power off and on. And of course, you can see the light sensor has recorded a level that indicates that it's bright enough, in this case because it's directly under a light. And it is going ahead and recording the date and time, the H2O level, which is the voltage reading across the probe here. Actually, it's a measure of resistance, actually. And then the temperature and the relative humidity. The temperature is in Celsius. It is pretty close. It says it's 20 degrees where it's sitting right now. That's probably pretty close. It's just a bit over 70 degrees here in my dining room. So there you have it. It is working. I want to do the one final test. In fact, I'm going to do this with you guys because I haven't done this yet. I'm actually going to stick this in my very sad geranium. He suffered a little frost damage at the end of the growing season, but we're gonna dump this in, and we'll see how that moisture reading changes when we have that plugged in. Okay, so I've moved everything up here. Tried to get it closer to my plant. And this is something you'll read about in the blog, that this is all well and good to do the prototype, but not exactly commercial grade. So I'm going to wait until the red light goes off on the temperature, or on the soil sensor, so that I know that there's no power applied. And that's off now, so I'm going to stick this right on into the plant there. You can see that that's set down in a couple seconds here. The red light's going to kick on. There it goes. And it is measuring soil. So if we look over here at the screen, what we should see is, sure enough, our voltage reading there, our resistance reading, has gone down in half. And that means that there is moisture in the soil that's allowing current to pass between the two sides of the probe. And that's exactly what we'd expect. And so there you have it. Our soil moisture sensor project is working as anticipated. One of the things that I'm doing in the background, you'll see it in the code, is I am recording the readings that I get to a MySQL database just here on my local machine, that will let me go in and look at the values over time later. And as I think about the longer term use of this, for monitoring multiple plants and different things like that, that database becomes a pretty integral part of that. So anyway, there you have it. It is wired up, running, working as advertised. So encourage you all to check out the companion blog that goes with this, as well as, of course, the GitHub repository. All the code is there. I've got another project that I've been working on that's in there as well, that I'll show you guys next time on the video. Really excited that this has all finally gotten to work. Okay, so there you have it. I hope this video was informative and helpful in helping you get started with your own Raspberry Pi projects. Again, please go check out the companion blog series. It has a lot more detail and notes about where this goes from here, and sort of what I've learned and lessons learned about getting started with an IoT project, working with it as a novice to IoT. Teaching myself as I go, and using a lot of resources and a lot of help that I've found online. And I hope that I've been able to communicate that stuff to you guys up to this point. I'm not done yet. Got a lot of other projects that I want to try out, a lot of other things that I want to do with our IoT gear. So check out the next one as soon as I get it posted, and hopefully this has been enjoyable. Thanks again for joining me, and we'll see you on the next one.